Welcome to this tutorial on dimensional repair using Elementiam software. In this video, we'll walk you through the process of identifying and repairing damaged volumes using a reference model. By the end of this tutorial, you'll have a clear understanding of how to leverage Elementiam to restore parts to their original condition. To begin, we start with a scan of the damaged part alongside a reference or nominal volume. This nominal volume serves as our baseline for comparison and can come from a variety of sources. It might be a CAD model, a scan of an undamaged spare part, or in cases where symmetry is present, a scan of an undamaged section of the damaged part itself. With these elements in place, let's dive into the steps for analysing the damage and executing precise repairs. The first step in the process is to overlap the nominal and damaged models. To achieve this, we use the superposition module within Elementiam, utilizing its accurate registration method. This powerful feature aligns the nominal model with the damaged one, ensuring precise positioning. This alignment is critical, particularly for in-situ repairs, as it provides the foundation for identifying the damaged volumes and planning the necessary corrective actions. Next, we move on to identifying the damaged volumes using the damage identification module. By setting a threshold value, this function analyzes the differences between the nominal and damaged models, isolating the areas that require repair. The accuracy of this process is determined by the threshold you set, allowing you to fine-tune the detection to match your specific requirements. Once configured, the module efficiently extracts all damaged areas, giving you a clear visualization of what needs to be addressed. Once the volume of interest has been extracted, we can proceed to the volume preparation phase. In the volume preparation window, you'll define a repair strategy that includes 3 key steps: pre-machining, material deposition, and final surfacing. For these steps to be applied correctly, it's essential to ensure clean surfaces and maintain minimum tool clearance. By specifying the main geometrical characteristics of the machining and additive tools used for the repair, Elementiam automatically generates optimized negative and positive volumes. This ensures a collision-free repair process that is both efficient and precise, tailoring the strategy to the specific requirements of the damaged part. The final step is generating the toolpath for both subtractive and additive processes. To accomplish this, we follow the same methods outlined in the additive and subtractive toolpath generation tutorial videos. These methods ensure the creation of precise, efficient toolpaths tailored to the defined repair strategy, seamlessly integrating pre-machining, material deposition, and final surfacing into the process. Once the toolpaths are ready, the repair process is set for execution.